Hey guys, look at you! You made it to 7.1, which is counting trees, sample spaces, and probability. Our objective today, students will be able to find probability using counting trees and sample spaces. Now back to our basic probability definition. In an experiment with a set, S, of equally likely outcome, the probability of an event happening is the probability of some event is equal to the number or outcomes in that event over the total possible outcome. So goes back to Algebra 1 definition. Let's look at an example. Exercise 1. Scientists are trying to determine how likely it is that a mouse will correctly maneuver through a simple maze to obtain food. The mouse can make 3 turns, either right or left, to get through the maze, but only get cheese if it's 2 left and a right in any order. So, if you notice there, I underlined the basic information. They can make 3 turns. So the first term is either going to be a left or a right, but again, he only gets food when it's 2 left and a right. A says, how can we draw a tree diagram to illustrate this? So, remember, this mouse can either go left or right. That's the first turn. Okay, so let's put this as 1. Oops, this is 1. 2, from this other turn, they can go left or right. And then this is their second turn. They can go left or right. Then one more turn they have. From this other turn, it's either left or right. Here it's left or right. And again left or right. And one more time left or right. Remember, up here it says 3 turns. So now this is my tree diagram. It says summarize the route. So I want to look at this. It's going to go right, left, 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 left. Then it can go left, left, and this right. So then I have left, left, right, left, right, left, left, right, left, left, right, right. All I'm doing is going to different routes. Now looking at this here, he can go right, left, left, right, left, right. That's this right here or this right here. Then it can go right, right, left, right, right, right. It says list the routes from part B that would result in the mouse getting the cheese. So if you look back up here, it says the mouse get the cheese when it's 2 left and a right. So I need to look for 2 lefts and a right. So let's get a different color. 2 left and a right, 2 left and a right, 2 left and a right, and what else? 2 left and a right. That's it. So it has left, left, right, left, right, left, and right, left, left. So there are 3 choices that this mouse can go. So it says what's the probability that it will get the cheese? So probability is equal to how many choices this rat has. 1, 2, 3. 3 choices of getting this cheese over how many choice in total? 1, 2, 3, 4, 5, 6, 7, 8. So your probability is 3 out of 8. That goes back to our definition. Total number of outcome over total possible outcome. So the outcome of the rat getting the cheese, he has 3 ways of getting the cheese, and then there are 8 possibility for the rat, the 8 different ways, the total ways, which is what we listed up there. Now it says Carlos is trying to grab 2 dimes out of his pocket, which contain 2 dimes and a penny. So he has 2 dimes and a penny. Assuming Carlos randomly grabbed 2 coins without replacement, what is the probability that he'll get 2 coins? So this is his pocket. What does he have? He has three choices. He gets a dime, let's call it dime 1, dime 2, and a penny. Okay? So it says he's grabbing 2 coins. It says what's the probability that he'll get 2 coins. So this is what he has in his pocket. Let's say the first grab he gets a dime 1. Then the two choices that are left is either he can pick another dime or a penny. He grabbed this. The other choice is he gets a dime and a penny. And then if he pick a penny first, then the other choice is either going to be a dime 1 or a dime 2. So it says draw a tree diagram, which we did. What is the probability that he will get 2 dimes? So if you look at this is one where he gets a dime and a dime. Here is another with a dime and a dime. So the probability would be 2 out of how many different cases he has. Remember, this is 1, that's 2, 3, 4, 5, 6 choices. So it's 2 out of 6, which is this, or probability is equal to 1/3. Okay? Moving along on to probability when it becomes a little complex. So probability can become a little more complex if the sample space gets larger. The last exercise in the lesson is an extended problem that involves playing a game called 3-person rock, paper, scissors. We all know the famous rock, paper, scissors game. In a normal 2-person rock, paper, scissors, 2 people can throw out a hand signal, rock, paper, scissors. Rock beats or crushes scissors. Scissors beats or cuts paper, and paper beats or cover rock. This game is often used to break ties. You know, most of the time you do let's play rock, paper, scissors, say shoot. In the 3-person version, each player will throw out a hand signal. Player A wins if all hands are the same. Player B wins if all 3 hands are different. And player C wins if 2 hands are the same. So this is a little exercise that we can do. Now, so let's say we were doing this as a group in terms of 3, and we would play the game rock, paper, scissors, say shoot, and then we'll tally. We're gonna do this 50 times, so we're gonna tally how much. Let's say player 1 won 1 2 3 4. I'm just making these numbers up. 1 2 3 4 5. Player A won 10 times. Player B won 1 2 3 4 5. 1 2 3 4 5. 1 2 3 4 5. That's 15. 1 2 3 4 5. That's 20. That's 30. So I need 10 more to make 20 more, because we're going 50 times. 1 2 3 4 5. Oops. 1 2 3. 1 2 3 4 5. 1 2 3 4 5. Actually, let's take, and I just made these up. Let's make this into 9, and let player C 1 2 3 4 1. So let's say we were playing, you and the 2 partners were playing, these were the outcomes. So this is how you would tally this, which we all know how to do, how to tally something. And then it says calculate the empirical probability. All that means, player A won 9 out of how many times? 50 times. Player B won 20 out of 50 times. And player C wins 21 out of 50 times. So now that we found the empirical probability, we want to create a tree diagram. So it's going to be a really large tree diagram. So we're going to start off with our basic. Remember, my starting point is going to be what? Rock, paper, scissors. That's my 3. Okay? And then I'm going to keep going. This rock can go into rock, paper, scissors. This can be the next toss, can be rock, paper, scissors. rock, paper, scissors. Those, remember, those are the three options that we have in this game. Then if I was to take this out, I can do the same thing. Rock, paper, scissors. Rock, paper, scissors. They all can be rock, paper, scissors. And this can keep going on all the time. Rock, paper, scissors. And this will be the same exact thing. It says list the outcome of the sample plays for player A. Now, if you go back to the problem, it says player A wins if all three of the hands are the same. So since there are only three choices, player A can only win if it's a rock, rock, rock. And then player P, paper, 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 scissor, scissors, scissor. And remember, we're doing this only 3 times because it says the player wins if all 3 hands. So that tells me how much time. So in this case, this is 1, this is 2, and then all of this will be 3. Now for player B, it says player B wins if all 3 hands are different, and player 2 wins if the same. So if all 3 hands are different. So what does that mean? So that means it can be any order. So the first order can be rock, scissors, paper. Or it can be rock, paper, scissors, paper, rock, scissors. Remember, it has to be all different. Ooh, why did I put a comma there? This one would be paper, scissors, rock, paper, scissor, paper, rock. So this person have 6 choices. It says, now, how many outcome are in the sample space in total? So in this total, it's asking you, so this has 1, then you can go 2, then you can go 3, and if you count this one has 3, you keep counting all the time, you're going to see that there is a total of 27 possibilities. Let's make that a little clearer. How many outcomes can player see? So the total is 27. Player A, so player A has 3 choices. Player B has how many? 6. So that total is 9. And then I want to see what's player C, question mark, but I know the total has to be 27. So this becomes 6 and 3 is 9. And you just break this down. 6 and 3 is 9. 9 plus what will give you 27? That's 18. Here it says find the theoretical probability. So the theoretical probability that A will win. A has 3 out of 27 choices. Player B has 6 out of 27 choices. And player C has 18 out of 27 choices. And those are my probability for this. Now, I know this was a long problem. So you know what to do. Go ahead and flip that page, work on those practice problems, and come see me for mastery. Remember, you made it to lesson 7.1, so don't say, I have no idea what's going on. You can do this, guys. Come on. I believe in you. You believe in you. See ya!